Let's talk about two special topics from section 2.3. The first thing we'll talk about is the conjugate trick. And then after that, we'll talk about the squeeze theorem, and we'll do one example of each. So first, the conjugate trick. I'm going to kind of explain what's going on, and then we'll dive into an example. Generally, conjugates look like this. You'll have some sort of subtraction between two terms. We'll just call them A and B as placeholders. The conjugate is going to be the same thing, but with a plus in it. So like complex conjugates will work this way if you've seen that before. So this comes out to a special product. Anytime you multiply two terms that have the same numbers in them like this, these binomial terms, but then different signs between them, you have this like magical multiplication where if you FOIL this all out and simplify, you should get a squared minus b squared, and like the middle term just disappears. We're going to take advantage of this special product for a very sort of simplifying a very tricky specific type of limit. Okay, so the limit that we are going to tackle is the limit as t approaches 0 of root of t plus 4 minus 2 all divided by t. So t is my variable here instead of x. If that drives you nuts, you can always just switch it to an x. We'll leave it here. All right, so this is a really tricky limit to compute exactly algebraically. Secretly, there's sort of a hole in this graph, but you can't really see it from here. There's nothing obvious to factor out or simplify. I can see that I can't plug in 0 because that would make me divide by 0 right away. So what we're going to do is take advantage of this special product to simplify the top. So I want you to see a minus b, see that as the numerator here. So your a is root t plus 4 and your b is the 2. So what we want to do is multiply it by its conjugate, so root t plus 4 plus 2, so that it simplifies out like this. So the magic here is that you get the a squared, you're squaring the root here, so they cancel out. So it essentially gets rid of the square root that was causing all the trouble. So we're going to throw parentheses around here because we want to multiply it by its conjugate. So same first term, same second term, and just a plus between them instead of a minus. It's just this sign that changes between the terms, not anything else. So you might be saying, you can't do this, right? You can't just multiply stuff into your limit. You've now changed the function in the limit. And you're exactly right, which is why we need to also divide by it. So if we multiply top and bottom by that same term, essentially we're multiplying times something equivalent to 1, and it's actually okay to do, even though it looks like it's going to make things worse. It's actually going to make things better in a really cool way. All right, so what comes out on top is this simplification. It's the kind of thing where like you take the number of steps that you're comfortable with here, don't rush it. So we have a minus b times a plus b. So what should come out is a squared minus b squared. And I'm going to take my time here because one of these has a root, one of them doesn't, and that makes it awkward. If for some reason in a different example, this second term had a root in it, those parentheses are definitely necessary because the minus sign would subtract after the square. So just be careful there. Okay, and then on the bottom, it's much worse, but we'll just kind of leave it how it is. Just t times all that stuff that had to come in. And then I'm going to simplify in this numerator here, right? So this square root and this squared cancel. Of course, 2 squared is 4. So my numerator becomes t plus 4, just on its own, minus 4 over that same denominator. I'm not even going to bother simplifying it because I don't need to. All right, so here's where the simplification starts to really pick up. You have plus 4 minus 4 up top. They cancel each other out, so you have just this t left over. Let me rewrite it one more time just to be clear. This t in the numerator is going to cancel with the t in the denominator. It kind of feels like there's nothing left on top, which means there's actually a 1 just on its own. So we have 1 over all this stuff. And as soon as we've done that cancellation with this guy here, we're actually able to plug in t equals 0 now, right? We saw the hole, we canceled the factors. So now we're able to just plug that number in. And we do. So we have 1 over, and it's just the stuff in the parentheses down there now. So I have the root of 0 plus 4 plus 2. Root 4 is 2, so my final answer here is 1/4. Isn't that neat? Okay, so generally examples like this, you'll start with a limit to compute algebraically. You won't be able to plug the number in because it'll make you divide by 0. And the key that kind of tells you that to use this trick is that there's a tough subtraction on top and there's a root involved. So then the conjugate trick, squaring things out, actually helps. You'll multiply in by the conjugate, top and bottom, and then pray that the simplification works in a really nice way.